If you would like to machine those 4 slotted profiles you see on your screen, you only need to define one, because we have the option in Tensor to make copies of a toolpath. So we need the center line of this slotted profile. The radius of the inner profile is 15, the outer is 25, so we need to define an offset of 5 millimeters. So we select the outer profile, move to draw other curves offset, and we'll enter a value of 5 on the right side, and there's our center profile. So the profile is already selected, so we can move on to NC Jobs, Machine Profile and Profiles, and we'll just start answering the questions, which will result into our NC program. Okay, we don't need a finishing. We'll program on the profile without tool compensation. Okay, so we don't need tool compensation. We would like a new tool, as we don't see a tool yet in our program, so we'll click on yes. The start height might be 20 millimeters, and we can select from our tool library the flat end 10 mil, as our slot is 10 millimeters wide. So we'll select the flat end 10 and click on OK, and answer a reference point of G55, for example, and then we enter the values of machining. The top of our material is Z0, the depth might be 5 millimeters, and we'll do this in one step with no allowance. Okay, now here we can choose for helical milling or per step. Let's in this case select helical. Okay, our retract height, approach height we can define, and in this case we do not need an approach, so we'll answer 2 without tool compensation, of course, as we are machining on our profile. And the helical tool path has been calculated now, and we can convert this into NC code. And would we like copies? We like to have a few copies, so we'll answer with yes. And either by rotation or by translation we can define our copies, so we'll in this case use the translate option, and we'll have 1 copy in X and 1 in Y, and you can see the values are already entered. It's 135 in X direction and 125 in Y, and we'll click on OK, and automatically 3 extra toolpaths are being generated. And if you take a closer look, you can see it's a helical movement. And if you want to see this in simulation, you can click on the eye, so this program left is being copied to the simulator, and we can click on the eye here, and you can see the simulator simulating our program. As you can see, it's a helical movement, and at the bottom of the screen you can see the machining time for these 4 profiles. So this is an easy way to program within Tensor. So you can see G code here, but this can be any kind of code like Heidenhain. This could be for if you look at woodworking, for Masterwood, Alberti, SCM machines, etc., etc.